I sure am now.
Okay, so just to review, we did type those numbers in, use the SS category, degrees of freedom, number of rows -1, number of columns -1. Great.
2, 5 expected. All right. The conditions for conducting tests for independence are satisfied. Oh, I'm still typing these in. All right. So 142. 178. Okay.
Why does it have that little thing that says you can click delete, click this to get the data?
I don't know. What are you talking about? Where?
Are you so you're on number like where right underneath the data that we're putting into Excel?
Uh-huh.
There's a little thing that says right click on the link below and select open tab, open link in new tab to download the data.
I don't know. Let me open it up and figure it out.
Great idea.
It's the same thing.
Oh, okay.
Yeah.
Okay, perfect. Okay.
So the conditions tests are true, from what I can see.
Okay.
And all the expected counts are above 5.
Degrees of freedom, did you get 8?
I sure did.
Oh, hallelujah. Test statistics 7.44. P-value 0.490.
Yeah.
Okay, so there is insufficient evidence, right?
Yeah. And I put there's insufficient evidence to suggest that motivation to visit a chiropractor is not independent of the location.
Okay. Hey, so question for you on the other rule, determining if it's a simple random sample.
Uh-huh.
You're just looking for what kind of sample it is, right? And then it says to obtain a sample from a single population. What does that mean? Obtain a sample from a single population.
So I think that's just if it was. Let me look. From a single population. I think that would just mean that it's just all from one thing. So if we decided to do a survey in a neighborhood, that neighborhood would be the one sample.
Okay.
So I guess like what he's talking about with our M&M thing, it's we're doing a cluster because we're putting it into groups.
Okay.
And so probably what we'll have to do to make sure we have a sample size big enough is just get those big bags
Yeah.
of it. So like if one of us got the peanut and one of us got the regular.
Do you think how many ounces are in those big bags? Should we get one big bag or two big bags?
Let me see. I googled it earlier. I'll have to Google again. I remember it was a whole bunch of M&Ms. How many M&Ms in a big bag?
Oh, you're saying okay, the big bags. Yeah, that's a lot of M&Ms.
Yeah, the bags that cost like $10.
Yeah, that's 42 ounces. Yeah, that should be
That should be plenty.
so much for my diet.
I know, right?
Okay.
Yeah, I'll call you back in a second. I'm on a group Skype call. I'm on a group project. All right, peace. Let's see, what all did he say that needed to be corrected on that thing?
Okay. The population should be all M&Ms. The sample, it is all M&Ms, right?
Yeah.
Okay. If the sample is that 8 that you're studying, the sample is the 8 that you're studying. Okay. So what I was thinking is, so you know right here in like the rubric,
Uh-huh.
it gives like kind of the description, the exact answers that he's looking for.
Uh-huh.
Like maybe we could use the same format, like the Microsoft Word document, and type it all in there or whatever, and then I don't know, just to like make sure that we have everything
Uh-huh.
perfect. Copy and paste the rubric at the bottom, and then relist like the research, the population, the null, and the, you know what I mean?
Yeah.
Okay, sample size too small. Each bag contains 30 M&Ms. Divide that by 6. You're only getting 5 or less of each color. ANOVA test requires a bigger sample.
So the population needs to change from 8 bags. Where's no? So our population is
More tunes, more versatility. America's most exciting lineup is a
Sorry.
so the population that we are observing is 42 ounce bags. So then the sample. Okay, so all M&Ms in general is the population. Okay. Two 42-ounce bags. One. So do we just do one plain and one peanut, or
That's it's up to you. Like,
I think that's enough. I mean, that's a huge population.
because if there was, so the normal bag of M&Ms is only like, let's see, let me look right here. The normal bag that we had was one, oh yeah, dude. So the normal bags that we were gonna buy were 1.69 ounces,
Okay.
and if there's 30 M&Ms and 1.69 ounces, then we're getting 42 ounces a piece.
That's a bunch of freaking M&Ms that I'm going to enjoy eating one day.
That's a lot of M&Ms. So, what is that? Where's my phone? So that's 746 M&Ms per bag, divided by 6 colors. So we're getting 100. We're almost getting like 250 sample of each color.
Okay.
But I'm assuming like in the milk chocolate, there's more M&Ms in that bag, like because the peanut ones are a little bit bigger. But I still think there will be plenty of like a sample size.
So this is what I put for the population. The population that we are observing is all M&Ms. Our sample will be two 42-ounce bags, one being plain M&Ms and the other being peanut M&Ms. This will give about 250 M&Ms for each color in a bag.
Perfect.
And then he said there was something wrong with my null and alternate. Please use proper notation for null and alternate hypothesis.
So are we supposed to use like HO and HA or?
I did that.
Oh wow.
So I wonder if he's just commenting on, because I had put plain does not equal peanut. I wonder if he wants the crossed out symbol there. I'll worry about that after we do our sampling method. So our sampling method will be a cluster.
Okay.
So then the groups that we put it in is by color, right?
Right. Dude, that's a lot of M&Ms. You hear me?
Yeah.
Yeah, I think because I mean we're increasing the sample size by almost 7 times what we had. So I think that'll like sample size will be good. What number are you on? On the
Number 3.
okay, null and alternative. State your null and alternative hypothesis correctly. How?
So I'm changing it to be plain M&M's color amount equals peanut M&M's color amount.
Okay. And then the other one is, because that one's worth 2 points, and the other one that's worth 2 points is describe in specific detail how your group will collect data.
Yeah, that's on number 4. I'm on number 3, which is the cluster sample, so I'm describing that one right now.
Okay.
The method we'll use is cluster. The groups that M&Ms will be placed in is by color. Is by color. And he wanted like specific detail of how we're making sure this is Random sample. Yeah. Cluster again. So for the cluster, like it gives an example of a researcher wanting to survey academic performance of high school students in Spain. He divides the entire population into different clusters. Then the researcher selects a number of clusters depending on his research through simple or systematic random sampling. So I'm thinking that what we'll have to say we're doing, so we'll separate them into their different colors.
Okay.
And then from that, we're going to have to somehow do a random sample of which colors we're doing to represent the entire population.
Okay.
So for randomly choosing that, we could just say that we typed in each color group into Excel, and then through a formula, it randomly selects which colors we use.
I think that sounds better.
So the clusters that the M&Ms will be placed into is by color. Use of we do randomly select just two different colors, because if we have 250 per color, that should be a big enough sample if we just do two different colors that it randomly selects. Here it says selects a number of clusters depending on his research through simple or systematic random sampling. But the sampling method we'll use is cluster sample. The clusters that the M&Ms will be placed into is by color. Then using the computer, randomly select, we will randomly select a cluster as our sample to observe if peanut and plain M&Ms have the same amount of M&Ms in that group.
Perfect.
I think that's what he's looking for.
Thank you.
Alright, so the sample size. So how you will collect data. two, six, then we will separate out into clusters M&Ms by color. Um,
Okay.
So I put the way we will collect data is by getting two 42-ounce bags of M&Ms, one being plain and the other peanut. Then we will separate out into clusters M&Ms by color. From there, we will input the data into Excel and randomly select, using Excel, a color to compare if plain and peanut M&Ms have the same amount in each color. I'm going to say that we're going to use, because in like the example I found online, it says he picks a couple different clusters.
Huh?
So I'm going to say on this we're going to do three uh, three different colors, so three clusters.
I think that sounds really good.
Okay. Why do you think this sampling method will give an accurate representation. A cluster sample will give an Usually I can BS things. I don't know how to BS this one.
Yeah, dude, I'm sorry. You definitely have better idea, so
No worries. I'm trying to think. So, how come would a cluster be the best with an accurate representation? Accurate representation because there will.
maybe you can put like a cluster would be the best, just because we're taking a sample from a very natural group. No, that sounds stupid. A very natural group that has like I don't know. That
So
all
I'm
kind
putting a cluster sample will give an accurate representation because there will be a couple different color samples that will with that will be observed with a large enough sample and randomly selected uh, giving um, samples observed with a large enough sample size. Variables. Cluster sample will give an accurate representation because there will be a couple different color samples that will be observed with a large enough sample size and randomly selected, giving an accurate representation of the population dynamics. I don't even know what to write for that. Like, that just sounds like crap, but. Let's see, what else? So we had. So that should cover our describe in specific detail. We state which sampling method. I don't get what the state your null and alternative hypothesis correctly, how we got that wrong. But I added to it, so maybe that'll help.
Okay.
Because I put plain M&M's color quantity equals peanut M&M's color quantity. Maybe I could change that to be per color quantity. Because if I put color quantity, that just sounds like the 6 colors
Sure.
in the M&Ms. So how could I word it to be the different... A little different.
The different cluster samples or the different?
So the quantity per color. So M&M per color. M&M's plain amount of plain equals amount of. I think that sounds a little better. No, dang it. Come on. Copy. Paste. Okay. Let's see if I can put in a does not equal symbol here. There we go. I want that. Right. Yeah, that'll work.
I'm sorry, dude. I'm zoning out.
No worries. I got the most ghetto looking thing right here. Because I found a does not equal symbol, but it's like, it's just like a word art, and so it's something you insert. And it's huge, and whatever, I don't care. It's presentable. Yep, that'll work. Alright, should I turn this one in and see what he says to this?
Absolutely.
Alright. File, save. Do you want me to send you a copy of it?
I think you're good, dude. It looks like he just updated it to mine as well, so.
Okay. Let's see here. Math. Group project, design the study, open. Okay, it says that I'm allowed to redo it, but it's not letting me submit. I'll have to email him about it. I saw a couple people mention that in class discussion, and it looks like he just hasn't really changed it yet.
Okay.
Alright, man.
Hey, dude. Great work.
Yep.